Okay, so first thing first, I was trying to find the actual symbol in Word. This is the degree symbol, which is not the actual symbol, but what we're talking about today is composition, which means that we're taking a function and putting it into another function. It is an open circle, but it's more centered. So it should look more like that. Okay, that's what it really looks like. It's not the letter O, but it looks like an open circle, but it's more centered. Okay, so when you see this first notation where it says F open circle G of X, that can also be written with parentheses without that symbol. And what that means is we're going to put G inside of F. G open circle F of X means put F into G. And if it's the same function, F and F or G and G, that just means we're putting whatever function it is, we're putting it inside itself. Okay, so eventually we're going to start actually building new functions, but the first step we're going to do is evaluate. And when you look at your homework, for the first two questions, it's just a part A, B, C, and D, where you're using the same function and answering 4 parts to it. And it looks very similar to the way I structured our notes. So let's go ahead and look at example 1. For example 1, you have 2 functions. This is my first function, and this is my second function. And we're going to evaluate it, but this time we're given a number. So we're going to start with the inside and work our way out. So we're going to actually begin by finding G of 5. So G of 5 that means I'm putting a 5 into this function here, which would be 5 plus 6. And we're getting a number. Now the number we get from the first step, we're going to put into F. So now you're going to find F of 11. So that would be 2 times 11 squared plus 1. Go ahead and type that in your calculators. And you should get 243. Is that what you all got? All right, so now let's look at the second example. For the second example, we're going to start with our F function, which is 2x squared plus 1. This time we're going to put a negative 3 into F. So let's begin by putting a negative 3 into F. So that would be 2 times negative 3 squared plus 1. And make sure you are using your, putting parentheses around that negative 3 when you type it in your calculator. And what did you get for that first one? 19. Who got 19? Okay, so now we're going to take that 19 and put it into F again. So we're going to find F of 19, which would be 2 times 19 squared plus 1. Type that in your calculator. And what did you get? 723? Is that what you all got? I don't remember getting that first period, but I'm going to trust y'all. Okay. All right, so now let's do our next 2. So for our next 2, we're going to start by putting in a 0 into what function? Which function am I starting with? F. So let's find F of 0. Which should be 1. And then you're going to find G of 1. And your final answer should be 7. All right, try to do that last question by yourself, and I'll put up the answer shortly. All right, who got 14? Any questions about how we did our first 4 compositions? Because again, these are the first 2 questions in your homework. I tried to structure the notes so it kind of followed the same flow as your homework. Okay, so now let's do that again, and this time we're going to use 2 different functions. So we have our f function, and we have our g function. So f and g. So what this is telling us to do first is start off with the g function. Go ahead and find g of 5, which would be 3 times 5, which is 15. And now take that 15 and put it into your f function. So we have a square root. We always simplify a square root if we can. Can we simplify 20? Is there a perfect square that goes into 20? No. 4, yep. 4 times 5 is 20. So your final answer would be 2 root 5. And that is how I expect you to, anytime you have a square root, you have to see if you can simplify it. All right, so let's find f of 4, which means we're using the same function. We're putting 4 into f. So we're going to find f of 4, which would be the square root of 4 plus 5. Which is the square root of 9, which is 3. Who got 3? Now you're taking 3 and putting it back into f again. So you're going to find f of 3. Which would be the square root of 8. Simplify that 8. Now, if you can't simplify it, for example, if we had a 7, we would just stop right there. But 8 does have a perfect square that we can take out, and that's 4. So we're going to simplify that down to 4 times 2, which would be 2 root 2. Okay, any questions about how we did those 2? All right, let's go ahead and do the bottom 2. So we're going to start by finding f of -1. So everybody figure out what is f of -1. And now, who got 2 for f of -1? So now put that 2 into what function now? G. So find g of 2, which is 3 times 2, which will be 6. All right, go ahead and find g of 2, which we already did. For the last one, go ahead and try to do that last one by yourself. Find g of 2. So you're using the same function twice. So g of 2 would be 6. And then you're going to find g of 6, which should be 18. And that would be your final answer. All right, any questions so far? Okay, so now we're going to start in example 3, we're going to start building functions. So do you see how we have an actual x in here? It's no longer a number like in our first 2 examples, which means that we're going to start building the functions. And we also have to state the domain. And as long as we don't have a red light, the domain would be what? All real numbers, negative infinity to infinity, correct? All right, so what this first one is telling me to do is saying put, I'm just going to write it. You don't have to write it because you already have this on your paper. But I'm going to put g inside f. So I'm going to put this g function right here inside of my f function. So f, what I like to do is whatever letter comes first, whatever function comes first, I rewrite that function and I put parentheses in place of x. So f of x says x squared plus 1. So I'm going to write it as parentheses squared plus 1. And then inside of the parentheses, I'm going to drop in x minus 6. So what I just did was I took that g function, which said x minus 6, and dropped it inside of my f function. Now you have to be careful here because you're squaring x minus 6. So that means x minus 6 times x minus 6. So go ahead and make a box, multiply that out. Or if you don't know, if you know the pattern, just write it out. Whichever way. Take x minus 6 times x minus 6. And you should get x squared minus 12x plus 36. Bring down the plus 1. So your final answer would be x squared minus 12x plus 37. And that would be your final answer. Who had that answer? All right, any questions about how we work through that? For the second one, again, I'm going to rewrite my f function with parentheses. So that would be parentheses squared plus 1, but this time I'm actually going to put f inside of the parentheses. So I'm putting the x squared plus 1. So I'm dropping f inside of f. So you'll need to make a box. And multiply the x squared plus 1 times x squared plus 1. All right, so that's going to give us x to the fourth plus 2x squared plus 1. Now bring down that plus 1 that was already there. Combine these together, and your final answer will be x to the fourth plus 2x squared plus 2. All right, so now let's find g of f of x. So let's put the f function inside of g. So we're going to work with the g function now. So my g function is a lot simpler because g says just take something minus 6. So when I write my function, I'm going to start off by putting a parentheses minus 6. So I'm parentheses minus 6. I'm writing my g function with parentheses. And now inside of the parentheses for the first one, I'm just putting f, which is x squared plus 1. Notice that in this function, nothing is happening. Or I shouldn't say nothing is happening, but the only thing happening to x is being multiplied by 1. So we don't have an exponent to worry about. So all I need to do is drop my parentheses and combine like terms if you have it. Sometimes you can't do anything. So not all compositions can be simplified. This is what it's going to simplify down to. Yes, all of these functions have a domain of all real numbers. Because none of our functions have a red light. In the homework, it tells you to state the domain. So most of them will have a domain of all real numbers. When we look at g of x, so my g function, again, says parentheses minus x. And now inside of the parentheses, we're going to put the same function, which is x minus 6. So I'm left with x minus 6 minus 6, which is x minus 12. All right, any questions about example 3? Yes.
Could you still use a box where it's just a
For which one?
for a 3 or 4?
Okay, so for these two, you don't need to make a box because nothing is being squared in the g function. So I had to make a box for the first two because x was squared. So I had to multiply it against itself. But in this function, g of x does not have an exponent, so we don't need to make boxes. All right, let's look at example 4. So we will have a restriction in our domain now because we have a function that has a red light. So let's start off with putting the g function. So I'm going to put my g function into f. So my f function says take the square root of something. And what am I taking the square root of? I'm taking the square root of g, which is 3x minus 1. So this is my function, but we can't leave it this way. I mean, that's my function. I'm done. But we have a red light. So for my domain, when we're writing our domain, it's going to be 3x minus 1 has to be greater than or equal to 0. Because you cannot take the square root of a negative. It has to be greater than or equal to 0. So go ahead and solve that for x. And that would be your domain. So your domain would be bracket 1/3 to infinity, because it has to be greater than or equal to 1/3. All right, let's go ahead and do our second one for our f. So for this function here, we're putting our f function inside of itself. So that means I have the square root of something, and then underneath I'm putting another square root of x. So it's like I have a double square root, which looks really ugly. But that is, and so I would accept this for an answer. But does anyone know the other way to write that instead of a double square root? We haven't talked about that, so.
Square root squared.
No.
Yes.
Okay, so we haven't talked about it, so it's, if you don't, that's okay. But it's actually the fourth root of x. So that would be another way to write that. So your domain is going to be, because it's still a radical, your domain, x has to be greater than or equal to 0. Which written in interval notation would be 0 to infinity. All right, couple more. So now we're going to put the g function, we're going to rewrite g. So my g function, now I'm working with my g function. G function says 3 times x minus 1. So I'm going to write that as 3 times parentheses minus 1. I'm using the same skeleton for these last two, because g function is the one I'm working with. For the third one, I'm putting f inside of it, which is just the square root of x. You cannot multiply this. There is nothing we can do. You cannot take a number times the square root. So your final function is just 3 square root of x minus 1. That's my function. And my domain is going to be x has to be greater than or equal to 0, because the only thing underneath my square root is an x. So my domain is x is greater than or equal to 0, or 0 to infinity.
So just focusing on what's under the root.
It's always what's underneath the square root. What's underneath the square root controls your domain. And for this last one, we're simply putting a 3x minus 1 inside of 3x minus 1. We don't have any square roots, no red lights, so you're just distributing the 3 and combining your like terms. So that'll give you 9x minus 3 minus 1, which is 9x minus 4. So that would be your function. And we don't have any red lights, so my domain is all real numbers. All right, and then that is example 4. Any questions over example 4? And then the last thing we're going to talk about is verifying that they're inverses. So when you do a composition, if you get x, that means that the two functions are inverses. We're going to talk about inverses a lot more tomorrow when we do 5.2. So for an inverse, that simply means that when you do a composition, you get x. You can't get x squared, you can't get x plus 2, you can't get x divided by 3. It has to be just x, 1x. All right, so when we look at this example here, we're going to verify that they're inverses. Again, if they're inverses, the compositions will give you x. So we don't need to do both compositions, we only need to do one. So I'm going to do, it doesn't matter if you do f of g or g of f. I'm going to do f of g, because if you get a x for f of g, then you're going to get an x for g of f. All right, so I'm going to start with my f function, which is this here. And my f function says 3x, so I have 3 parentheses. Inside of the parentheses, you're going to put your g function. And then check to see what you get when you multiply this. What is 3 times 1/3? If you need a calculator, feel free to type it in. So you should get 1x, which means that the answer is yes. Well, it's not saying show, but that's how you show it. You show it by doing a composition.
But you don't have to check the other one.
You only need to do one. All right, so for our last one, let's go ahead and do our last one. So we have to figure out if we want to do f of g or g of f. I'm going to do f of g again. So that would be 5 minus 2, make your parentheses. And then inside of the parentheses, I'm going to put my g function. So the first thing I think you should do, because we got a lot of multiplying going in here, I would not multiply this 1/2. That would be kind of ugly. But what I would do, what I would start off doing is multiplying these two numbers. I would multiply the 2 times the 1/2 to get rid of one set of our parentheses. Because that's a pretty easy thing to do. We all know that half of 2 is 1. So what that's going to give me is just a 1 right here. So now you can distribute the -1. And you get 5 minus 5 plus x. And then 5 minus 5 is what? 0, and you have 0 plus x, which is x. Okay, there is a textbook at the bottom. Feel free to use that at this time to start working on homework since it is due Thursday.